Hello, this is Christopher Lillian-Stolpe, the CTO for Solutions here at Tigera, and we introduce you to another episode of Container as a Service Academy, or CaaS Academy. And today we're going to talk about container runtime environments. And we call them container runtime environments because there's actually multiple container runtimes out there. The most common one, of course, being Docker, but there are other ones out there. Well, let's talk a little bit about what a container runtime is and why it's important. Obviously, it's sort of important. If you can't run your containers, then a container is a service. Doesn't really make a lot of sense. So if you remember what we talked about earlier, potentially, depending on what episodes you've seen or not, if we take our host, and on our host, what we used to have was a Linux kernel. We still have a Linux kernel. And part of this was a virtualization engine. And then above that, we had libraries and packages. And some of those libraries, some of those packages especially, also manage this virtualization environment on the host. So the kernel took care of creating a virtual machine image by creating memory isolation, network I/O isolation, etc., resource assignment and quotas. And then you had software packages running on top of that, provided a management API to that process that was happening basically within the kernel. And that's how you would then spawn VMs up here. And those VMs the enforcement of those VMs was actually down to that VM engine, or the kernel mechanics that provided VM support. So that was virtualization, how virtualization worked. Let's talk about containers and how containers work. So I'm going to erase this, go back to this basic host, and we'll start talking about containers and what does a container runtime do. We've gotten rid of all that VM stuff, and now we're going to do containers. One thing I forgot to mention previously was that the VM environment, the other thing that VM management software, those packages did, was basically loaded a image, be it an ISO or something, gold master, if you want to think of it that way, into the virtual machine itself, so the virtual machine could boot and run as a virtual server or virtual host. Now let's think about containers. Whereas before the kernel was doing a lot of virtualization, usually that VM layer was actually representing capabilities in the underlying CPUs. In container land, there's a couple of things that happen. We're going to focus on Linux. Windows has similar capabilities. But one, there are some capabilities in here. There's something called C groups and namespaces. So kernel has some primitives that we can use to make containers. So one of these packages, let's blow this package out a bit, is actually going to be your container runtime. So this package right here is actually this big thing here called your container runtime. What does the container runtime do? First of all, whatever's orchestrating, either you're manually telling your container runtime to create a container and how to do that, or you're feeding it, usually by feeding it some config in a standard file format, or you're running an orchestrator, say like Kubernetes, which in turn is going to communicate to the container runtime. How the information gets in here is not a topic for this conversation. But what comes into here? First of all, I say I want a container. Potentially with some options or restrictions. Maybe this container needs to run in the host namespace because it's actually going to manage this host itself. Containers normally don't run in the host namespace. They run in their own isolated namespace, their own isolated C group. We'll talk about that in just a second. So that they are independent of the host and they can't do things to the host. The host can still do things to them, but they can't do things to the host. But maybe I want this to be what's called a privileged container. It's going to be running in the host as pretty much a process in that host. Maybe I want to limit how much CPU or memory or network, etc. this thing can do, but I feed this into the container runtime. The container runtime is then going to go make some calls into the kernel, usually through a library. And what's going to happen is we will now create a container. What that container is normally a fenced-off execution environment. So that container uses C groups to isolate its memory space from everything else. So it can't, as far as it's concerned, it has a certain amount of memory space. It doesn't see any of the other memory space on the host. Same thing for CPU. Same thing for, say, device instances or proc file systems, etc. It has got its own file system root, independent of the host. So it has its own file system tree. It has its own networking namespace, so it has its own networking stack. So as far as the rest of the world is concerned, this is a different node than the host. It can't talk to the host over the network even unless the networking process, which we've talked about earlier or later, depending on what order you read these things in, can protect or allow that connection or deny it. So basically, I now have an isolated sandbox. And again, that's done by using these things like C groups and network namespaces in the kernel. The next thing, I tell the container what code should run. So this might be a pointer to a pre-built container image. It might be a pointer to a Git release, or it might be a pointer to a repository. We'll talk about repositories a little bit later in another session. But basically, now I tell the container runtime, either here, this is how I want you to build